In this video, we learn about square wave generator using operational amplifier. What is an op-amp? An op-amp, that is an operational amplifier, are linear devices that have all the properties required for nearly ideal DC amplification and are therefore used extensively in signal conditioning, filtering, or to perform mathematical operations such as addition, subtraction, integration, and differentiation. An operational amplifier is fundamentally a voltage amplifying device designed to be used with external feedback components such as resistors and capacitors between its output and input terminals. These feedback components determine the resulting function or operation of the amplifier, and by virtue of the different feedback configuration, whether resistive, capacitive, or both, the amplifier can perform a variety of different operational, giving rise to its name of operational amplifier. An operational amplifier is basically a three-terminal device which consists of two high impedance input. One of the inputs is called the inverting input, marked with a negative or minus sign. The other input is called the non-inverting input, marked with a positive or plus sign. A third terminal represents the operational amplifier's output port, which can both sink and source either a voltage or a current. In a linear operational amplifier, the output signal is the amplification factor known as amplifier gain A multiplied by the value of the input signal and depending on the nature of these input and output signals. We'll see the idealistic characteristics and parameters of an op-amp. First is the open loop gain. The main function of an operational amplifier is to amplify the input signal, and the more open loop gain it has, the better. Open loop gain is the gain of the op-amp without positive or negative feedback, and for such an amplifier the gain will be infinite, but typical real values ranges from about 20,000 to 2 lakh. Next is the input impedance Zn. The input impedance is the ratio of the input voltage to the input current and is assumed to be infinite to prevent any current flowing from the source supply into the amplifier's input circuit. In is equal to 0. Real op-amp have input leakage current from a few picoamps to a few milliamps. Next is the output impedance Zout. The output impedance of the ideal operational amplifier is assumed to be 0, acting as a perfect internal voltage source with no internal resistance, so that it can be supply as much current as necessary to the load. The internal resistance is effectively in series with the load, thereby reducing the output voltage available to the load. Real op-amps have output impedance in the range of 100 to 20 kilo ohm. Bandwidth. An ideal operational amplifier has an input frequency response and can amplify any frequency signal from DC to the highest AC frequency. So it's therefore assumed to have an infinite bandwidth. With real op-amps, the bandwidth is limited by the gain bandwidth product GB, which is equal to the frequency where the amplifier gains becomes unity. Common mode rejection ratio CMRR or common mode rejection ratio of an op-amp is defined as the ratio of the closed loop differential gain AD and the common mode gain AC. Note that the common mode gain AC of an op-amp is the ratio of the common mode output voltage and the common mode input voltage. Slew rate. The slew rate is the rate at which the output of an op-amp can change with respect to the input. It is measured as a change in voltage in given time. For an ideal op-amp, the time delay is 0. Hence, according to the equation, the slew rate for an ideal op-amp is infinite. Square wave generator. One very simple and extremely useful op-amp circuits based around any general purpose operational amplifier is the square wave generator or the astable op-amp multivibrator. The op-amp multivibrator circuit, however, can provide us with a good rectangular wave signal with the use of just four components, three resistor and a timing capacitor. The op-amp multivibrator is an unstable oscillator circuit that generates a rectangular output waveform using an RC timing network connected to the inverting input of the operational amplifier and a voltage divider network connecting to the other non-inverting input. Unlike the monostable or bistable, the astable multivibrator has two stages, neither of which are stable as it is constantly switching between these two states with the time spent in each state controlled by the charging or discharging of the capacitor through a resistor. So in this video, we have learned about what is an op-amp, the characteristics and the parameter of an ideal op-amp and square wave generator. Thank you. Now we'll learn about the operation of a square wave generator. Assume there is no charge stored in the capacitor initially. Then the voltage present at the inverting terminal of the op-amp is 0 volts. But there is some offset voltage at non-inverting terminals of op-amp. Due to this, the value present at the output of above circuit will be the positive voltage at saturation. Now the capacitor C starts charging through a resistor R1. The value present at the output of the above circuit will change to the negative voltage at saturation when the voltage across the capacitor C reaches just the greater than the voltage positive value across resistor R3. The capacitor C starts discharging through resistor R1 when the output of the circuit is the negative voltage at saturation. The value present at the output of the circuit will change to the positive voltage at saturation when the voltage across capacitor C reaches just less than, that is more negative the voltage, more negative value across resistor R3. Thus the circuit will produce a square wave at the output. The output of square wave generator will have one of the two values, positive voltage at saturation and negative voltage at saturation. So the output remains at one value for some duration and then transition to another value and remains there for some duration. In this way it continues. Now we learn about the waveform and frequency range of a square wave. With a resistor value between 100 to 1 kilo ohm and a capacitor value between 1 to 1000 microfarad, this would give a frequency range of between 1 Hz to 1 MHz high frequencies, produce square wave generator distortion. Standard TTL logic gates do not work too well as square wave generator due to their average input and output characteristics and distortion of the output waveform and low value of feedback resistor required. This results in a large value capacitor for low frequency operation. The oscillator may not be oscillate if the value of the feedback capacitor is too small. Unstable multivibrators can be made using better CMOS logic technology that operates from a minimum to maximum supply such as the Smith's inverter. So in this video, we have learned about what is an op-amp, the characteristics and the parameter of an ideal op-amp and square wave generator. Thank you.